My dear students, today we are going to discuss very easiest problem from numerical methods. Find a root of x log x base 10 minus 1.2 is equal to 0 by Newton Raphson method, correct to 3 decimal places. So this is a very easiest problem. So before we are going to proceed the problem, so kindly give like symbol and subscribe this video, share it with your friends. Okay, let us move to the problem. Given f of x, x log x base 10 minus 1.2. So and also we are going to apply Newton Raphson method, so that we have to differentiate one time. F dash of x will be, so u into v, that is the formula. Minus 1.2 is a constant, so it becomes 0. So x u log x base 10 v. Okay, so that f dash of x is equal to log e base 10 plus log x base 10. So this is a primary work. And the next one, so I'm going to substitute for x any two values. So that particular value gives minus to plus or plus to minus. Okay, so why we are choosing these random values? We have to find a positive root, isn't it? So that we have to randomly choose any two. It may be minus or plus. Okay, but the f of x should become negative to positive or positive to negative. That is the idea. So which are the suitable values? If I put 2 for x, so 2 log 2 base 10 minus 1.2, it gives minus 0.598. It is a negative value. Similarly, I am going to apply another value, that is 3. So it becomes, so f of 3 is equal to 3 log 3 base 10 minus 1.2, it gives 0.231. It is a positive value. So that we have to fix these two values, isn't it? See the result of the value, minus 0.5 plus 0.2, isn't it? Or plus 0.2 to minus 0.5. So whatever may be. So the thing is, from negative to positive or positive to negative. That is the idea. Now I am going to take modulus for both f of 2 and f of 3. So the result become, which is the greatest value? 0.5. Even though it is a minus 0.5, put modulus, it becomes 0.5 plus 0.5 and 0.2. So 0.5 is the greatest value. So that the root lies in between 2 and 3. So from 2 and 3, I'm going to select x not equal to 2.7, isn't it? That value is closer to, I think, 3, isn't it? So if you put 2.7 to the f of x, it will give, I think, negative value, isn't it? So that randomly I am choosing in between 2 and 3, that is 2.7. So this is a formula, xn plus 1 is equal to xn minus f of xn by f dash of xn. Now I am going to substitute n is equal to 0. So the formula becomes x1 equal to x naught minus f of x naught by f dash of x naught, isn't it? So we don't have the value for f of x naught and f dash of x naught. Now 2.7, substitute 2.7 in f of x and f dash of x. So the result will be, yeah, this is, okay. X1 is equal to, this is the answer, okay. 2.7 minus f of 2.7 divided by f dash of 2.7. So the result will be x1 is equal to 2.740. So I am choosing after decimal, 3 decimal places. So already given in the problem itself 3 decimal places. So similarly I am going to take, put n is equal to 2, put n is equal to 1. So it will become, left side become x2 is equal to x1 minus f of x1 by f dash of x1. So substitute the value for x1 2.74. So x2, the next value x2 become 2.741. Okay, and then now I am substitute this one. N, put n is equal to 2. So x3 is equal to x2 minus f of x2 divided by f dash of x2. So I will get x3 is equal to 2.741. See, this is x2. See the x2 value. x2 is equal to 2.741. Similarly, x3 is equal to 2.741. So it is repeated. So until the value is repeated, you have to put the iteration, isn't it? So here x2 and x3 are same value, so let's stop the process. So the required positive root is 2.741. Thank you, my dear friends, my dear students.